Alrighty, so you're curious as to why we use PEMDAS. Why on earth do we have to excuse my poor dear Aunt Sally? You know, she's gotten a lot of abuse. Well, I'm also curious as to why we use please excuse my dear Aunt Sally. And I've looked for the answer and I've not found one that satisfied me. I've basically run into the age-old math teacher expression of, well, we do it because that's just the way it is. And I found that usually when uh, encountered with that's just the way it is, there's actually really a reason. It's just the person who's trying to answer it doesn't know. So I'm going to attempt to explain what I see in Please Excuse My Dear Aunt Sally using the basics of what each operation means. Okay, I'm going to start with a review of adding, multiplying, and exponents, what they mean, and therefore that will lead us to kind of at least seeing a pattern, if not a definitive why. We can at least see the pattern among these operations. I'm going to focus on the accumulating operations, and by accumulating I mean you're accumulating wealth. That means you're getting it. So adding, if you're adding, that means you're increasing your value. If you're multiplying, you're increasing your value as long as it's a positive number. The same sort of relationship exists between division and subtraction as well, but just to make it easier, I'm going to stick with the accumulating operations. So on your base level here, you've got adding. And so if we have John has 4 apples, Juanita has 4 apples, and Joey has 4 apples, how many apples do they have altogether? Well, they have 12. And that works great in a simple story problem like that. But what if we're talking about Miss Johnson's class of 20, and each of her 20 students have 4 apples? You could write 4 plus 4 plus 4 plus 4 plus 4, 20 times, but that would make your hand hurt. So the mathematicians decided we're going to write a shortcut for that. We're going to say, well, each student has 4 apples. There's 20 students, and we're going to call this little symbol times. So 4 20 times. And that way we don't have to add 4 plus 4 plus 4 20 times. This is a shortcut method. So really what multiplying is a more elevated or evolved operation compared to adding. Think about building a house. The addition is the brick, and the multiplying maybe is the wall. So this wall is made up of bricks. Now further, when we have exponents, if we have 4, and let's say we have 4 times 4 times 4, okay? These 4 people email 4 people, and these 4 people email 4 more people. That's easy enough to do. But what if we've got, again, 20 iterations of emailing? That's going to grow really fast, and I don't want to write 20 times. So I would say 4 to the 20th power, which is actually kind of a big number. That would be a lot of emails. But I'm just trying to illustrate that an exponent is just a shorthand way of writing multiply. So again, this is the brick, this is the wall, and you could say maybe this is the manufactured house, which, are I guess cheaper than real houses, but they don't appraise in value according to my mother, who's a real estate agent. But I don't care about all that. So what we basically have is, if you wanted to take apart the house, for instance, you're going to want to start with the home itself, take apart its walls, and then separate the walls out to the bricks. That's kind of a way to look at it. It's not a real good explanation as to why, but I'm just showing you the pattern between these operations. This is a more evolved operation than multiply. Multiply is a more evolved operation than adding. And to be quite honest, we could write 4 to the 20th power using only adding. It would take us forever to do it, but we could. And I think that that's the reason for having these operations is obvious. What's not so obvious is why we have to take them apart in that order. So maybe if you think about the more evolved exponents have to be done before we can go down to the more simpler multiplying, and then finally the simplest of all, the adding. Now this grouping symbol here is actually probably more visual than anything else, and it leads to flexibility within the ordering system. So if you have 4 minus 3 times 2 plus 7, we would have to do this multiplying first. But with the parentheses, if we were to insert these parentheses here, that's a real visual cue. I think it's almost a natural visual cue that your eyes are drawn to this. So I think that's maybe why they used that. And this is to, the parentheses, the grouping symbols are there to give us flexibility within this numbering system. Because, you know, and I can't think of anything offhand, there are times when you want to go beyond this basic ordering and evolution of operations. So the parentheses or grouping are used primarily because they're visually, they visually lead you to notice them first. So it's kind of like a natural thing to want to take care of those first. For the rest, it's just about evolution. So this is visual. Exponents are the most highly evolved operation. Next comes multiplying. You know, exponents are made of multiplying. Multiplying is made of addition. Okay, I hope that was at least a little bit helpful. If you have a different explanation or a better way of explaining it, I would love to hear from you. Good luck and keep on doing the math.